Hey guys, Richard Holder here. Where are my HEMI fans? Whether you are a mild HEMI fan or a wild HEMI fan, I have something for both of you, and guess what? They're both turbocharged. In this video, we're going to take a look both at a mild HEMI turbo combination and a wild HEMI turbo combination. And actually, the engine combination stayed the same. The only thing that we changed for each of these combinations was the turbo itself. You see, if you take a 600 horsepower turbo and apply it to your motor, you can make 600 horsepower. If you put a 1,000 horsepower turbo on your HEMI combination, you can make 1,000 horsepower. Ultimately, the turbo dictates how much power you can make from your turbo HEMI. Let's take a look. To illustrate our mild and wild HEMI combination, basically to show you what happens that with the turbo that you select for your combination is ultimately going to dictate what the power potential of your motor is. So if you want a milder combination, 600, 700, 800 horsepower, it's funny that 800 horsepower is a mild combination, but something in that lower power range, you choose the turbo accordingly. And the same thing for much higher. If you're looking for 4-digit power levels, then you choose a turbo to run 4-digit power levels, something that will support that power. The cool thing is it can be done on the same engine combination. You see, the engine itself doesn't really dictate what the ultimate power is. That's turbo sizing. So this will be a cool test to take a look at. So we put together a healthy Gen 3 HEMI combination. It was actually bored and stroked slightly. We went from the 3917 bore. We bored it out a little bit to a 3937, so we went 20 over on it, and then we stepped up in stroke with a scat stroker crank from 358 to 3795. So a little bit more stroke. Basically, it's about the size of a 6.1 liter, but just with a different bore and stroke than the production 6.1 liter. This thing also had 6125 4340 forged rods. It had pro pistons with 10cc dish, or a dome rather. And we had early Gen 3 HEMI heads that were ported by the guys at Total Engine Airflow. So that porting improved the airflow dramatically, up from 260 CFM to 315 CFM. So it made those heads flow about what a good set of production LS3, LS heads flow. We also put a good camshaft in it because that's going to help this thing make power. A HEMI has really good head flow and it has a good intake manifold. In this case, we ran the aluminum SRT8 manifold. We could have run at this power level and this RPM. We could have also run the Magnum or even the truck manifold because all of those work fairly well, but we ran the aluminum one. So we put a camshaft in it that would allow us to take advantage of the intake and head flow. The camshaft was a 589 lift, a 239, 247 degree duration split, and 114 degree lobe separation angle. And what we did was run this thing NA with a fast XFI management system. We had, in this case, it did not have long tube headers on it. It actually had the SRT8 exhaust manifolds on it. So I never got to run this combination with long tube headers that I could remember to find out how much extra power the long tubes would be over the SRT8 manifolds. Now we know that the SRT8 manifolds offer a power gain over the factory Ram truck manifolds, which are very small and tight against the block, kind of more of a log style. So the SRT8 manifolds are definitely an upgrade from that. Now I don't know how much more. I would think that the long tubes, traditionally, they help improve power, down low. Those the factory SRT8 manifolds are kind of what I would consider like a mid-length header. So they actually perform fairly well, and they worked very well. We used them also for our single turbo kit. Though we use those exhaust manifolds, which the factory exhaust manifolds are a good way to go. They retain the heat and they work pretty well. So what we did was run this thing NA. So run with an optimized air fuel and timing. This thing made 522 horsepower and 56 foot-pounds of torque. So as you can see, we had a good start on our NA combination, stepping up in displacement and head flow and cam timing and stuff. This was a good baseline starting point. So now let's take a look and see what happened when we added the smaller of the turbos that we applied to this base motor. After running our combination, our Gen 3 HEMI combination, the little stroker with a cam, ported heads, and the SRT8 manifold naturally aspirated, it was time to install boost. And we did that using a single turbo kit from the guys way back when at HP Performance. They're no longer in business. But basically what it did was, using the stock SRT8 exhaust manifolds, it merged into a Y and then mounted the turbo up in front of the engine. So we could mount, this had a T4 turbo flange on it, and we could mount the turbo, any T4 turbo that we wanted. So we ended up running a variety of different ones, and we could take a look at, this is our milder combination. We also, so we started off with a 76 millimeter, a T76 from CX Racing. It was one of the turbos that we used on the Big Bang motors, on the Big Bang LS motors, both the 4.8 and the 5.3 that I originally did. So it was a single one of those. And then we had that turbo blowing into a single core air-to-water intercooler, also from CX Racing. And the core was good. We, as we'll see, we used it in applications that are much higher output than this mild combination actually produced. So it was a good core, and it worked well. It's also important to note that on this NA combination on the HEMI, we modified the factory throttle body to work as it was a drive-by-wire throttle body. We welded on a flange to make it operate mechanically. And we also had to machine the front the front cover, the timing cover on the engine to make the throttle body fit with the SRT8 manifold, or because this was originally from a truck, the 5.7 was a truck motor, a Ram truck motor. And we could put a different front cover on there from an SRT8, but we didn't happen to have it. So we just took it over to mill and machined off the area so that the throttle body and the linkage would fit without any problem. So we were blowing through the factory 5.7 HEMI truck throttle body into the SRT8 manifold. And so what we did was install the single turbo kit using the SRT8 manifolds, hooked up the air-to-water intercooler. We ran dyno water through the air-to-water intercooler, and then we installed our T76 turbo. And here's what happened when we started off with about 7 pounds of boost. And as we've become accustomed to, we picked up quite a bit of power. The power output jumped from 522 up to 672, so we picked up 150 horsepower, which was a nice gain. 635 foot-pounds of torque, and we did what everybody else did. We go up and boost just a little bit here, up to 765 horsepower, and that worked out well also. But we were getting to kind of the limit. What happens is on this particular turbo, this is about the most that we've made from that. And what we're seeing is we have a lot of boost down low, and then we have a falling boost curve on this 76 millimeter turbo. So it just it can't support the power level of this kind of NA combination. It works better in the 700 horsepower or even kind of this range, since we really kind of twisted it up. But from the 700 horsepower and down range, that T76 is good. If you want a little bit more, the GT45 seems to work fairly well. There are obviously other smaller combinations, but this goes to show you that adding even just a little bit of boost can yield some good power gains, especially when you're starting out with a combination that's already fairly healthy. And for you guys that want to know what kind of timing we ran, the NA combination made peak power at about 28 degrees of timing, not how much boost, but how much timing. 28 degrees of timing. And then these were about 21 degrees under boost. And when we installed the turbo, we did add 100 octane race gas in mix with the 91 on these lower boost levels. But then when we stepped up, which we're about to, with the bigger turbos and go for the wilder combinations, we put 112 octane race gas in it. This was done long ago, before we were using a lot of E85, so this was all done on race gas. So let's check that out. Stepping up from our mild to wild combination, all we had to do really was step up in the turbo sizing. And as I said, the turbo sizing ultimately is what dictates the power output of the motor. So if we put a 700 horsepower turbo on our combination that can only support 700 horsepower, that's how much power you're going to make. But if we put a turbo like this 80 millimeter turbo from Comp Turbo, or the Precision Turbo, the 7675 that we ran, those things can support 4-digit power levels. So ultimately our combination can make 4-digit power levels. The turbo sizing is what dictates it, and then the NA combination determines at what boost level you're actually going to make that at. So that should be easy to understand. So we have our NA combination here. We have the same turbo kit. All of that is the same. The only thing we did was take off the small T76 from CX Racing and put on this bigger comp turbo. And unfortunately, I don't have specs on that comp turbo other than it was listed as an 80 millimeter. That's all I unfortunately have in my notes. It was plenty capable of supporting this power level. And we ran this at 15.4 pounds. As I said, we ran it on race gas. We ran it on 21 degrees of timing. Here's what happened when we installed the bigger turbo. And as you can see, it's fairly easily up into the 1,000 horsepower range at a peak of 15.4 pounds on this turbo. And we're running all of these tests with a manual wastegate controller, basically a simple bleed valve and a single wastegate. And unfortunately, I think that the single wastegate, and especially on this combination, was maybe a little too small. We had a rising boost curve on this. This thing would also have, and I didn't measure it like I should have, but this thing would also have very little back pressure compared to that smaller T76. The T76 back pressure probably would have been fairly high because we're kind of taxing the limit of that. The NA combination made a lot of power. The turbo can only support a certain amount. The hot side of that is not very efficient. So we had a few problems obviously with the smaller turbo, but run with this bigger 80 millimeter turbo, this thing made 1,011 horsepower and 867 foot-pounds torque. You can see we've got some, good gains. We made peak torque out near 5,900 RPM. So this thing would have continued to rise, especially with our rising boost curve, because that's what happens if you have a rising boost curve. You can actually artificially change where you're making peak power. And we saw the same thing. The next thing we put on was a Precision Turbo, a 7675, and this was a billet wheel CEA. I mean, this thing had all the bells and whistles on it. Here is what happened when we ran the 76. And we actually ran the 76 at a slightly higher boost level. The peak boost on this one was 16.2 pounds, but it had more boost basically through the whole curve, and it made more power as we would expect. That one made 1,051, and peak torque checked in at 913 foot-pounds of torque. So again, these are both easily 1,000 horsepower turbos, and probably more than that. And so when we applied them to the same base motor that we ran the smaller turbo on, we're able to make fairly easily, 4-digit power level. So again, the turbo determines what the ultimate power output is going to be of the NA combination. Let's get to our conclusion. Okay guys, what did we learn from our pair of Gen 3 Hemi turbo combinations? First of all, we learned Gen 3 Hemis can make a lot of power. They have very good cylinder heads, they have good intake manifolds, and with a little boost, everything wakes up. But on this combination, we had a good camshaft, we had good ported heads, and we used the SRT8 intake manifold. So right off the bat, we were making over 500 horsepower. And here's the thing, anytime you start off with over 500 horsepower, getting to 1,000 horsepower doesn't really take very much boost. But the one thing it does take is the right size turbo. If you put a turbo on there that allows you to make over 1,000 horsepower, it will definitely do that. And as we saw, it's fairly easy. But let's face it, not everybody wants 1,000 horsepower or more turbo Hemi. Some guys just want 500, 600, 700 horsepower, and you can also do that with turbo sizing. I'm Richard Holder, guys. Make sure to like, share, subscribe, ring the bell, do all that stuff. More turbos coming up.